All right, question number 7. Yeah, now these are important. I really want you to see these kind of questions because so you're not surprised by what happens on the real exam. Take a look at this. This is a slightly different style than we saw in the homework. So I want to show it to you, go over it with you carefully so that you're ready to go on exam day this week. So question number 7. An airline claims that the no-show rate for passengers booked on its flights is less than 6%. Right? So, people that book a flight but then don't show up, they claim it's less than 6%. Of 380 randomly selected reservations, they're going to test it by randomly selecting reservations. Maybe the manager or something is going to test it. 14 were no-shows. Perform a hypothesis test at the 0.05 significance level to test the airline's claim. What is the conclusion? And then all they have here is words. Look at that. So sometimes I give you just words at the end. Sometimes I'll just give you a p-value. Sometimes I'll say reject the null, don't reject the null. We did a lot in our hypothesis test, and I can't test you on everything in just one question. So in different questions, I'll test you on different parts of your understanding of the hypothesis test. All right, so let's go through it. So what do we do on a hypothesis test? Well, what we have to do, oh, wait a minute, let me come on down here. What we have to do is go to the notes. So let's look over here at the notes. So I'm on the exam 3 notes, hypothesis test setup and conclusion. So here it is. And we're going to get all that on the screen. Probably too much. Okay, let me just go to here. There we go. So there we go. So I'm going to grab the notes, come over here, and now this crazy thing is not letting me do what I want to do. It's driving me a little nuts here. All right, so I'm going to have to pull in the file again. Sorry, hold on one second. It's being difficult. So I have to go back down there again. All right. Here we go. In fact, I think I'll just grab it, put it on its own separate page. There we go. All right, there it is. This question 7. All right, and I'm going to add the notes down below it. There we go. Okay, so all right, so here's the notes. What are we supposed to do? What's the first step on a hypothesis test? Write the claim from the words. And it's either going to be P or U, equals, does not equal, greater than or less, right? That's the first step, not the HO, not the H1. First step is what? Claim, claim. So I've noticed in the past, a lot of students want to skip over that step and they want to go right to the calculator and do all that stuff. That's not a good plan. You really need to do the first step, which is writing the claim. So let's write it. And that's in the words. So you got to practice reading these words. What do they claim? That the no-show rate is less than 6%. So is this a mean problem? Is this a U? Remember, that means that's actually standing for the Greek mu, which is mean, average. Or is it a P? Is it a P or a U? Is it percentages or is it averages?
Percentages or what?
Percentages or averages? Is it percentages or mean? Mean is average, right? This one's percentage, right? There it is right there, percentage. So I'm going to use P. And what are they saying about P? Less than 6%, less than 0.06. Change that to a decimal like we always do, right? 2 places back, 0.06. We good there? That's what's being claimed, isn't it? Everybody good with that? Remember, the greater than, less than symbol's like an alligator. It's open mouth towards the bigger one. So it's saying the P is less. The P gets the narrow side of the symbol. The 0.06 is the greater one. The P is the less. So the no-show rate is less than 6%. That's what's being claimed. Now, from here, we write the HO and we write the H1. How do we do that? Let's go look at the notes. The HO is always equal. See that? And you know that, right? HO is always equal. So HO is going to be P equals 0.06. Same number. We never changed the number, whatever number the claim was using. And then the H1, how do we know what H1 is? Well, it says either HO or H1 must be the same as the claim. Option 1, if the claim is equals, no, the claim was not equal. The claim was less than, right? So we're not taking option 1. We're taking option 2. If the claim is greater than, less than, or not equal, then H1 will be the claim. Boom. That's right. H1 is the claim. What's the claim? Right here. So P less than 0.06. Remember, one of those two has to be the claim. Always. Every time. One of those two has to be the claim. So if the claim was equals, and sometimes it will be, we'll see that on the practice exam today. Sometimes the claim is equals. In that case, the claim would be the same as HO. But in our case, this problem, the claim is less than, so the claim is actually H1. One of the two is always the claim. Remember, this is like a two different attorneys in a court of law. The prosecutor and the defense, HO and H1, they're arguing with each other. HO is saying P equals 0.06, and H1 is saying, no, it doesn't. P is less than 0.06, which is what is being claimed. So HO is disagreeing with the claim. H1 is making the claim. And they're saying different things. And we're going to decide where the evidence points. The evidence, the statistical evidence in this problem, does it go towards HO or does it go towards H1? They're always in conflict with each other. All right, how do we figure that out? Well, next step, let's go down to hypothesis. So write weak evidence next to HO, write strong evidence next to H1, always. So this is weak. It takes weak evidence to conclude HO. Strong, it always takes strong evidence to conclude H1. So write that. All right, next step was about the p-value and stuff like that. So now we're going to go to our calculator. So let me add a page here, and we'll go to our calculator stuff, which is down here. Hypothesis test using the calculator. So I'll put that back in here for us. Okay. All right, so hypothesis test using our calculator. What are we gonna do? Do we have a P percentage? We do, right? Use one prop Z test. See how that's test? One prop Z test. That's where we're going. All right. So I'll come on down here. On my calculator, I'm gonna hit stat. Go over to test. Right. Go down to one prop Z test. And hit enter. Right, so I got that off the notes. One prop Z test. And when you hit it, there's number 5, I think. Yeah, number 5. One prop Z test. Number 5, hit enter. All right, and then you get the options. And what pops up on the screen is P0, X, N, and then the proportion. Okay, so here we go. Let's fill in the details. What is a P0?
Is it O?
Yeah, good job. Good job. Exactly. That, and that's going to be throughout the rest of the course. We're going to get after this week, starting next week, we're going to, now that we have these down, we're going to go to messier and fancier hypothesis tests. And the tests will get fancier and fancier, but you remember, whenever they have anything with a little zero, they're pointing to the H0 number. That means you just grab the number next to H0. Exactly. Good job. That's your key to know. So no matter what, when they get fancier and fancier in the weeks to come, you just remember, hey, if it's got that little zero, I just grab the number next to H0 every time, every time. Good. So that should be easy for you. Now, what about the X? What's that going to be? Well, we can go down and look at the notes here. What does it say about the X? It's the number asked for. Again, it's the number asked for, just like it was a minute ago. Number asked for over total number. So number asked for over, so what number are they asking for? What are they asking for in this problem? They're claiming, which is kind of how they ask things on a hypothesis as they make a claim. They're claiming something about the no-show rate. So they're claiming something about no-shows. So they're asking about no-shows, aren't they? So how many no-shows?
14.
14. There it is. Out of how many total? 380. That's the total. And then the proportion, you just always do the same as H1. It's same as H1. So what's H1? Less than. So you just choose the less than option. So put that into your calculator. I'm putting it in my calculator right now. And hit calculate. And so what I get when I do all that is I get a p-value. And really all I care is the p-value. Let me show it to you. P-value is 0.0286. That's good enough right there. 0.0286. So y'all getting that okay? You could round it. I don't care. They're not asking me for the p-value. That's good enough. They're asking me for the conclusion. So now it's time to make the conclusion. How do you do that? Well, let's look back at the notes. Here's the notes. And it's saying, oh, I need to add a little bit. Add the notes there. Add them right here for us. Grab them. It's, it's really needs to be 2 pages. Yeah. So I guess I'll do option 1 and option 2 separately. Okay. Option 1, option 2. All right, back we go. Good deal. Option 1. Boom, there it is. Perfect. Down here, option 2. Yeah, beautiful. All right. So there you go. So what are the 2 options for your conclusion? Well, I've made this, highlighted it, did all I could to make it as clear as I can for you. P is low, meaning P is less than alpha. Here's the saying, when the P is low, the null must go. This means when the p-value is low, less than alpha, the null must go away. That is, reject the null. We keep H1, strong evidence. Same thing down here. If P is greater, that's option 2, P is greater than alpha, what's the saying in that case? When P is not low, the null must not go. This means when the p-value is not low, meaning it's greater, the null HO must not go away. That is, fail to reject the null, and instead we keep the null, weak evidence. Okay, so that's the saying. Let's go back. When the P is low, the null must go. That's our saying. So what is the p-value? What is our alpha level? Do you see the alpha level on this problem? Does anybody see the alpha level? right here. Let me highlight it for you. I want it to be really clear. There it is. There's your alpha. That's your alpha. So alpha is 0.05. Here, let me move this over so it's more easy for everybody to see. So the P came out to be 0.0286, and the alpha is 0.05. That's the alpha significance level. So the question is this p-value right here greater than or less than that alpha?
It's less than.
Less than. 0.02 is less than 0.05. Yeah, exactly. It's less than. Less than. So that means the P is low. The P is less. The P is less. So if the P is low, the HO must go away, right? Remember the saying. If the P is low, meaning less than, that's low, it's less, it's small, it's low. If the P is low, the HO must go away, meaning we're going to reject the HO. We're going to come back up to this HO and go, nope, you lose, right? Remember, we're the jury deciding which attorney we agree with. So we reject the HO and then we keep H1, don't we? We keep this one. This is what we conclude. This is our conclusion. We're always, in the end, we're always going to go with either HO or H1. How we know is about the p-value and how it compares to the alpha level. So the alpha level is how strictly they want us to test. They want evidence lower than 5% chance of luck. That's what the p-value and the alpha are all about. They're about the chance that the evidence was just lucky, right? Because that's always the problem. Anytime you test anything in the real world, how do you know you just didn't get a weird sample, right? They're testing for COVID right now. They tested on 100 people or they tested on just 10 people, and 8 of them seemed to be resistant to COVID. They seemed to be vaccinated. Maybe that was just a lucky group, and those 8 people weren't going to get it no matter what. Maybe the drug's not doing anything. How do you know you just didn't get lucky? Well, that's why you try to grab a bigger sample and do things like that. So there's always the chance of luck. We want to make sure it wasn't just lucky, but the drug or the claim of the no-show rate or the whatever is really the truth. And it wasn't just a lucky sample. How do you know that? That's the p-value. The p is the probability it was just a lucky sample. Well, there's only a 2% chance, 2 or 2.8% chance that it was just a lucky sample. And they said, as long as the chance is less than 5%, that's what the significance level is. It's how tight, how strong they want the evidence. They want evidence below a 5% chance of luck, like a court of law, right? Beyond reasonable doubt. They want it to be pretty sure. So we're saying the p-value came in less than alpha. So it was strong results. There was only a 2% chance of luck, which is lower than the 5%. They wanted it below a 5% chance of luck. We got it. So the p indeed is low. The null must go away. Bye-bye null. We reject the null and we keep H1. All right. So with all that said, and that was a lot said, what's our conclusion? H1. We conclude H1, don't we? Let me write it here. Conclusion. H1. We believe that statistical evidence is strongly in favor of. Why do I say strongly? See it right here? Strong. If we'd gone with HO, that's always weak, but we didn't. We crossed out HO. We rejected HO. We're going with H1. So we're saying strong evidence. There's strong evidence in this case for what? For the p-value, for the proportion being less than 0.06. Don't confuse this p with the p-value. I should write p-value here. We have a lot of p's going on here. So the p-value is low. There's strong evidence that the p, this means the percent of no-shows. No-shows on the airplane. So we're saying the percentage of no-shows on the airplane, there's strong evidence that the percentage of no-shows on the airplane is less than 6%. All right. So which of these options? There is sufficient evidence to conclude that the true percentage is less than 6%? Yeah, that's exactly it. There it is. See how the other ones are wrong. This one says there's sufficient evidence to conclude that the percentage is not less than? Not less than? No. There is not sufficient? No. Sufficient means strong, right? Sufficient means enough. There's strong evidence. So we can forget about this not sufficient options. And then this one's not true because it says not less than. So here's the right answer. Sufficient evidence, strong evidence to conclude that it's less than 6%. There we go.